In this video, I'm going to show you how to solve square root radical equations. And in particular, we're going to focus on the case where the right-hand side contains a square root. So here we want to solve this equation, root of x plus 2 minus root of 3x minus 4 equals 0 on the real numbers. Right now the right-hand side is 0, but as we manipulate this equation, the right-hand side will turn into a square root. Let's think about how we might simplify this equation. It looks pretty tempting to square both sides to get rid of the roots. That'll give us x plus 2 and then a minus 3x minus 4, but there will also be an in-between term. The middle term will be negative 2 times root x plus 2 times root 3x minus 4. So we'll still have a root even if we square it, just because we've got to do the whole foiling process, not just square both of these. But there is one thing that we can do to make our life a little bit easier. Why don't we just add this root 3x plus 4 to both sides to get it on the right hand side? And so then we'll get root of x plus 2 is equal to root of 3x minus 4. And now we can just square both of these sides without worrying about any middle terms that come out from foiling. We'll just get rid of the roots directly by squaring them. Okay, so square both sides. Square left hand side and square right hand side. The left hand side, you just get rid of the root, comes out to x plus 2, and right hand side, get rid of the root, just 3x minus 4. And this equation is just linear, it's easy to solve. Let's start by subtracting x, so just 2 equals 2x minus 4, then add 4, get 6 equals 2x, divide by 2 and get 3 equals x. Great, so we've got a value for x. But one thing to watch out for is that sometimes the act of squaring can sometimes generate additional solutions which aren't solutions to the original equation. So we need to get into the habit of checking the solutions that we find by plugging them back into the original equation. So let's do this quickly off to the side over here. If we plug in 3 for x here, we get root of 3 plus 2 minus root of 3 times 3 minus 4 is equal to 0. So that's root of 5 minus root of, this is 9 minus 4, so 5 equals 0, and 0 equals 0. Good, so this does work, so this is okay. In a future example, we'll see an example of the solution that doesn't work. But for now, this is all good. Okay, so now we've got another example. I want to solve this square root radical equation, root of x squared plus 3x minus 5 equals root of 4x minus 3. And why don't we start off by just squaring both sides to get rid of the roots. So let's write that again. X squared plus 3x minus 5 is equal to root of 4x minus 3. Take the square of both sides, that gets rid of the roots. Then we've just got x squared plus 3x minus 5 is equal to 4x minus 3. And this is a quadratic, so let's go ahead and simplify it. We'll subtract 4x from both sides. X squared minus x minus 5 equals negative 3. Then add 3 to both sides. X squared minus x minus 2 equals 0. And then factor this quadratic. So factors of negative 2 that add to negative 1. That'll be x minus 2 and x plus 1 is equal to 0. And then use the zero product property. So x minus 2 equals 0 or x plus 1 equals 0. Solve both of these independently. X equals 2 or x equals negative 1. And let's double check each of these solutions. So starting off with x equals 2, let's go ahead and plug that back into the original equation. We get root of 2 squared plus 3 times 2 minus 5 is equal to root of 4 times 2 minus 3. So root of, what's this? This is 4 plus 6 minus 5 is equal to root of 8 minus 3. And 4 plus 6 is 10, then minus 5 is 5, is equal to root 5. So great, root 5 equals root 5, and yeah, this checks out. This is a good solution. Okay, and let's take a look at the other one as well. So checking x equals -1, let's do the same thing here. So -1 squared plus 3 times negative 1, then minus 5 has to be equal to root of 4 times negative 1 minus 3. So root of 1 minus 3 minus 5 has to be equal to root of negative 4 minus 3. 1 minus 3 is negative 2, minus 5 is negative 7. That has to be equal to root of negative 4 minus 3 is negative 7. But although these roots are equal to one another if we're in imaginary numbers, we are only on the real numbers here. So these roots aren't real valued. Therefore, x equals negative 1 isn't going to be a solution of the equation. So nope, it's only this one, only x equals 2. Here's a final example. I want to solve this equation, root 2x plus 1 equals root x plus 1 on the real numbers. What we've been doing in the past is just trying to rearrange the equation so that when we square both sides, we won't have any square root terms, but that's going to be kind of unavoidable here. If we square both sides here, we're going to have a middle root term from the right-hand side, but if we move that root over to the left-hand side, then we'll still have a middle root term. So this equation, we're going to have to solve it in 2 steps. We're going to have to square both sides once, then isolate the root, and then square both sides again. But nevertheless, let's just go ahead and proceed. So we'll write that equation down again. That's 2x plus 1. The root of that is equal to square root x plus 1. And we'll just go ahead and square both sides and see what we get. So squaring removes the root on the left-hand side. We just get 2x plus 1 is equal to, and then FOIL the right-hand side, so just root x squared, so just x, then plus 2 times 1 times root x, so just 2 root x, and then plus 1 squared, so just plus 1. Okay, now let's go ahead and subtract x from both sides, get x plus 1 is equal to just 2 root x plus 1, and then subtract 1 from both sides, x is equal to 2 root x. And while we're at it, why don't we isolate the root here? So divide by 2, just do x over 2 is equal to root x. Alright, so we're not totally there yet, but we've simplified the equation a lot. Now it only has 1 root instead of 2. So why don't we just bring it over here and we'll do the whole process of squaring both sides again. So I have x over 2 squared equals square root of x squared. And the result of that will have just x squared over 4 is equal to x, just x, yeah, okay. So now let's go ahead and solve this quadratic equation. Why don't we start by getting rid of the fraction, so multiplying both sides by 4. We'll just get x squared is equal to 4x, and then let's go ahead and subtract off that 4x, get x squared minus 4x equals 0. We can factor that into x times x minus 4 equals 0. And then zero product property gives us 2 solutions, either x equals 0 or x minus 4 equals 0. That's already solved, and then x minus 4 equals 0 comes out to x equals 4. If we were to substitute both of these solutions back into the original equation here, we would find that they both work. And as an exercise, I'd encourage you to go ahead and try that yourself and just ensure of it. So now we see how to solve equations that involve multiple square roots, and in the future we'll also learn how to solve equations which involve cube roots as well as higher index roots.